All right, area of a triangle. We have a formula for the area of a triangle. Do you guys remember what it is?
Base times height.
Say again?
Half of the base.
Yeah, area for a regular triangle. Well, that looks like an H. Area equals 1/2 times the base times the height, right? Sprite? Kite. Tight. Excite. Thermite. Termite. Bright. And light. Spite. Delight. Trite. And fight. Here's the thing. We're not always going to have the base and the height. But if we have an angle in between, there's a new formula. So if we have a picture, I'm going to draw a picture. This would be the height of the triangle. I'll call that H. The base would be B. And we'll call this gamma. We'll call this A. So sometimes we don't have the base and the height. But there's a way we can get around that if we have one of the angles. So that's what we're going to look at right now. If I was writing some equation involving H and A, well, what's the sign of Y? For this picture, what's the sign of gamma? Not sign of Y, sign of gamma. So just from this, sign of gamma is H over A because it's the opposite from the angle, opposite over the hypotenuse. But that's just for this smaller triangle, yeah? But the H is the height of the bigger triangle. If I solve for H, I can multiply both sides. Can you guys see this? I'm going to do it in orange. I can multiply both sides by A. So I get H equals A times sine of gamma. Do we see this? I'm using this. This is not going to be like an example, but I'm using this to create a new area formula in case I don't have the height, but I also have an angle. So instead of writing this area formula, 1/2 times base times height, I'm going to replace the H with what I got using this angle gamma. So a new formula that we can also use is going to be the area is 1/2 times the base, and instead of H, what can I write?
A times sine of gamma.
Yeah, A sine gamma. The only requirement or the only condition to use this formula is gamma has to be the angle in between A and B. So I'm going to write that. If it's not the angle between A and B, then the whole way that we found this for the height, the whole way we found that would be wrong, because if it wasn't the two in between, then H wouldn't be H anymore. It would be like A divided by something else or whatever. The reason why gamma has to be between A and B is because of the way we found this formula by using the sine of the inside of the triangle. So that's the only condition. This is a formula that you're going to use, so I'm going to box it. You're going to use that to find the area for all these problems. Sometimes you'll have to use the law of cosines or the law of sines to find an extra side. And then after you do that, then you can use this formula. Yeah. Everything here is set up easily. You don't have to solve for anything else. Find the area of the triangle when A is 8, B is 6, and gamma is 30. I'm going to let you guys try that. So for this, if I start solving it or start using the formula is A, or area equals 1/2 times times B times A sine theta. Sine gamma. What is it? I don't know what I'm saying. That's the one. First, I'm going to draw a picture because that helps me make sense of the problem. I'll call this B. I'll call this B. This will be A. So 8. And then, since that, okay, that would be alpha. That would be beta. So this has to be gamma. You have to make sure that the angle is in between. Otherwise, you have to do a little bit more work. But the angle is in between the two sides, so I can continue on. Now it's recording, so don't swear or anything.
I swear not to swear.
So area will be 1/2 times A, which is 8, times B, which was 6, and sine of 30. Sine of 30 is 1/2. Did anybody remember that without putting it in the calculator? I hope so. That's good. So that'll be 1/2 times 6 times 8 times 1/2. 8 times 1/2 is 4. 6 times 1/2 is 3. So this would be 12 units squared, 12 square units. I don't care if you write the units because they don't give you units. Example number 2, well, that's the answer for number 1. The example number 2 says find the area of the triangle with sides 4, 5, and 7. First, you'd have to draw this, and you need an angle, so you can use something to find out what the angle is. And you could use a bunch of different ways, 3 different ways to do this, because you could solve for any of the 3 angles of the triangle, but you should try that. So the first thing that I would do is draw the triangle. And it really doesn't matter how you draw it, just because we don't know what it looks like anyway. 5 and 7. And then between the 4 and the 5, or between the 7 and the 5, or between the 4 and the 7, I would have to pick one of those and use it. It doesn't matter which one. Does anybody have a preference? The top angle, the left angle, or the right angle? Anybody care? Nobody cares. Okay, I'm going to use... It's too late. All right. I'm going to call the top angle alpha then. I don't know what's going on. There's actually... I probably should have called it gamma just because that's what our formula says. But it doesn't really matter what you call it, as long as you're using now these 3 things, because we have the sides and the angle in between it. So first I'll use the law of cosines, and that will be, well, I have to do this one squared equals the other 2, right? So 7 squared equals 4 squared plus 5 squared minus 2 times 4 times 5 times cosine of alpha. I would get cosine by itself, and then alpha, that was in the other video, so I'm just going to write down alpha. If you solve for that top angle, you should get 101.536959 degrees, just by using the law of cosines. And then after that, we can plug it into our area formula. So A equals the sides around the angle. So we have 1/2 times 4 times 5 times sine of 101, blah, 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 blah. And then the area, if you multiply that out, is approximately 9.80 units squared. And I don't care if you write down the units squared part. If they don't give you units, I don't care.